Hello. I might as well get started. After seeing a lot of the talks this week, the setup of my laptop went pretty quick, so should be a good one. Welcome everyone. My name's Doug Schaefer. I'm the CDT project lead. I've been so for over 10 years now. Kind of thought give you kind of an update. There's a lot of new things that we've been working on in CDT over the last year. Some of them I think are really cool, and I think will really help C++ developers who want to use Eclipse. So we'll talk about where we are and kind of where we're looking to go in the future. So first thing up, so CDT this year reached a kind of a milestone. We reached our 15th anniversary. CDT was one of the first projects at Eclipse, if not the first, that involved essentially companies outside of IBM. It started as from a contribution by QNX Software Systems, which I now work for. And basically we had built an IDE back then based on Eclipse, kind of a bit of a copy of JDT, but made it work for C and C++ development. And but really that's not our core business. We wanted to do it in the open. And Eclipse was a great place to do that. And we were able to get a number of companies to help us kick it off, including the Rational, which is where I was working at the time. But there was also Red Hat and a few other RTOS vendors that were coming along. So it was good. It was a good place to start. And we've been around a long time, and we've had a lot of people come and go, and CDT has just kept evolving over the years. So there are some new people here. Just a quick overview. So what is CDT? So it stands for C++ Development Tooling, which really doesn't tell you anything. But really it's tools to help developers who are programming in C and C++, use the Eclipse environment and take advantage of the Eclipse ecosystem, really. Help them basically build an IDE for them. And it's a platform, really kind of started as a platform for tool vendors and platform vendors to hook their things up and take advantage of the common features that you get with CDT. But also has a powerful editor and source navigation. So there's actually two parsers. There's a C and a C++ parser in CDT that tries really hard to understand your code. And I think it was Martin Lippert yesterday made a point that, yes, we wrote C++ parser in Java. But it was really necessary evil in order to take advantage of all the great features that people saw with JDT, the content assist, open declaration, finding references, those kind of things. But it's really turned out really well in the end. And it's really, CDT is a foundation of, there's an Eclipse package called the C++ IDE package. And this is really what users who come to Eclipse looking for a C++ IDE, that's what they use. But there's other things that go in there like Git, and there's actually Myelin in there as well. But CDT is really kind of the foundation of that, and we kind of are the caretakers of that package. But over the years, so it was, you can't just have a platform. It's got to be usable by people. So we really picked the GNU tools as a starting point, supporting GCC and GDB as compiler and debugger. It's pretty ubiquitous. At the end of the day, GCC is kind of everywhere. So that was a good choice, and that let us show off to the community what kind of stuff the CDT can do. But over the years, we started climbing up the stack a bit more. There's some really interesting platforms for C++ developers, especially things like Qt, which has its own kind of build system that we need to be able to integrate with, and there's a QML language that used to declare the UI. So we're trying to add support for that. There's SeeMake, which is another build system that's becoming more popular in open source projects. So we've added support for that. Arduino, and I'll actually show some of this stuff in a demo later. Arduino is really interesting because it's, how many people are familiar with Arduinos? They're little hardware boards that hobbyists kind of get used to. That's how they get into electronic engineering and writing software for these little boards. It's a really interesting environment because they're so small. There's no operating system. You're writing bare metal code. It's kind of scary when you think about it. But we've tried really hard. There is an IDE that the Arduino community use, but it's more like a notepad for software engineers. So we have, being the CDT guy, I wanted to add support for that so that I can use it and not be kind of annoyed by that IDE. And kind of looking down the road, we really want to enhance our support for cross-development. Raspberry Pi is another popular target that people are using. It would be good to have cross-support for that, so you can use CDT for those environments. Some interesting stuff happening with remote build. So I don't know, Jeff Johnson gave a talk yesterday about our work on supporting Docker as a build environment. And that's something we've seen with large compute servers as well, where people are taking advantages of the big iron in order to do builds. So we want to add support for that. CDT has huge adoption. Tracy Miranda put out a request on the CDT dev list, just trying to figure out how many different vendors use the CDT in their products. And it just, dozens of companies came out of the woodwork. So it's really cool to see that. It really has become the industry standard C++ development environment, especially for embedded. So it's everywhere. Pretty proud to see that. So next thing I wanted to do is kind of show off CDT a bit. Let me put my chair up. So one of the things that a group of us are working on is support for the latest C++ standards. So C++ is an evolving language. A lot of people who don't work in it don't realize that. C++ 11 was kind of the first upgrade to the standard in a long time, and a lot of interesting new language features came in. Now they're on a cadence where they're doing it every 3 years. There's more and more things getting added to the language. So we're working hard to try and keep up with that. And I'll show some of the cool stuff that we can do. So this is really not your old C++. So one of the cool things, and this is the one I want to highlight, is the auto typing. And it's interesting that the next version of Java is supposed to have something similar. So C++ is actually ahead of Java in this area. This came along with C++ 11. So in this example, you can use auto as the keyword. If you've used the standard template library and you've written iterators in the past, they're actually really wordy. So this thing actually maps to the vector with the template arguments, : iterator. So you don't have to type that anymore. You just go auto I. Even cooler now, you can do for loops just by, if you have a container that is compliant with the API, the generic API, you can just simply go auto I thing. This is, again, very similar to the way Java works now. And the CDT is figuring this out. So not only is it knows what type, it's inferred the type just like the compiler would. You can do things like control-click to go to the definition of it. And of course, things like content assist work. So you can see the I has been resolved to the right type, and we can follow through and all that stuff. So there's a lot of work that goes into the CDT in order to keep up with the languages or the language updates. We also have refactoring. This is also a not very well-known feature. I don't really have a demo of that prepared, but we have things like extract function, where you can select a bunch of code inside of a given function or a method, start up the extract function refactoring. It works a lot like the Java refactoring does. And we use, again, the CDT's built-in parsers and the ASD it produces in order to figure out how to make the change, how to, which variables are being used in that block of code so we can pass them in as arguments. Very powerful stuff. And we actually have a university group from Switzerland that does a lot of work in that area. And they actually have a product which actually has more refactorings built on the same engine. So it's pretty powerful. There's a picture. And for debugging, I just wanted to highlight a couple things. And these are actually things I used in the last couple of weeks. There's a memory browser, which actually talks to the debugger to get the chunks of memory so you can take a look. In this case, it was very helpful because I'm writing a device driver for a board support package. I was curious what all the register values were at every given time. And this was actually able to show me it. That was pretty useful. We have things like the disassembly view, things you don't have to worry about in Java. But often when you're writing hardcore device drivers or something very low level, you want to actually see what assembly codes. And if you don't trust the optimizer of the compiler, you actually want to see what the assembly code is. And you can actually step through them, each instruction by instruction. So moving CDT forward. So that's kind of the cool stuff that we have. Some of the not cool stuff that we have is some really old architecture. Again, being 15 years old, again, people have come and gone. So the current build, especially the build system that we use called managed build, it's very heavyweight. It was started really kind of so that we can do things like what Visual Studio does with its build properties pages. But then we took it even a step further to the point where we can figure out what builds to do. So you don't even need make. We actually have an internal builder. But it was very heavyweight. And as time went on, there's actually the newer build systems, things like SeeMake and Qt's QMake, that kind of do the same kind of thing, just have a different way of entering the information. But it was really hard to work with the old system. So we started working on a new build system for CDT called Core Build. And really, it was kind of peeling away the onion. We took, there's a lot of things that the managed build system did that, at the end of the day, when we go back to what the CDT needs out of a build system, it was just, we can actually make things a lot more simpler and a lot more flexible. So things like CDT needs out of it is things for those parsers. So the include pass and the macros that are used passed on to the compiler, so that we can parse the same way the compilers do. And part of it is just being more automatic. So we focused a lot over the last couple of years on user experience. How can we do things? A lot of, especially new developers that are setting up C++ projects, you don't care what the compile options are. You can tweak, there's some compilers that have like thousands of options. But when you're a beginner C++ developer, that's you just want something that you can quickly get up and going. So we do a lot of things with the launch bar, which I'll show a bit more, and the build system's kind of in that same light where we want to generate build configurations automatically and not have the user have to worry about that. So currently, this new system supports Arduino. Supports the Qt QMake build system and SeeMake. And we're looking forward to move pretty much everything else that we have on top of it. There's actually a contribution from Intel on the auto tool support, so things like AutoConf and AutoMake. Next thing I'm going to be working on is adding the makefile support, where you just write your own. It's kind of like what we call the standard build in the old day. Where you write your own makefiles, or it doesn't even have to be make. It could be just scripts or whatever. And really, that involves being able to parse build output and understand, again, what the compile options are. And then eventually, we'll hopefully move the whole managed build, keep that same kind of UI that we had with it, but have something simpler under the covers that just focuses on the options and generating makefiles from it. It also uses, there's a new project template wizard that we've created There's an old CDT templates, which were very confusing and hard to build. And actually, the old C++ new project wizards were very confusing and complicated. So we're working on simplifying that as well. So the next thing I want to demo is Arduino stuff. So one of the things we're able to do, so one of the great things about Arduino, well, first of all, one of the hard things is that there's hundreds and hundreds of different boards and different types of boards. And a lot of them have their own compilers and their own SDKs. But the Arduino community they've defined a metadata so that you can describe the SDK and the tools, and then the IDE can then take that and actually generate the build for you. So the user never sees any of that. So with CDT, I've created an Arduino downloads manager, which manages downloading those SDKs, or packages as they're called. There's also a set of libraries that you can use. I wonder if this is going to work. Nope. I guess I did that work. Shouldn't hit the add button. So anyway, we'll get back to that once it times out. So yeah, so you can define, it downloads these SDKs for you, and we got these metadata files, and it generates the build. And that's time out quick. There we go. So again, this is the libraries that you can, and there's again dozens of libraries. So every peripheral that you can hook up to these boards, and there's a lot of different hardware vendors that we support. And they all have their little devices, and basically this provides libraries for that stuff, which is pretty cool. So let's take a look. So I have an example. We'll do a quick. So this is the launch bar. How many people know about the launch bar? A few people. So the launch bar is kind of a UI element, and it's actually fairly controversial. It's a UI element, and we kind of hack it into the toolbar so that it's always on the left. And it's not exactly, looks the same as everything else that's in the toolbar. But really, it's a familiar experience that we're trying to achieve. If you use Visual Studio or use Xcode, there's a similar kind of element, UI element that you use to, and really what it's doing is selecting, what thing do you want to build or launch, what kind of mode are you launching in, and this is really the same as the Eclipse launch modes. And then, but also introducing the concept of target. Where do you want to launch it on? Like what kind of board? So we take advantage of that with the Arduino IDE. So I have a ESP8266, which is it's kind of a Wi-Fi chip with a microcontroller, and they added Arduino support for it so that people can program that microcontroller. And you can create those using the new launch target, and there's some settings that you can provide, and it changes based on the different board types. So this is how you configure what your board's going to look like, and that controls certain parameters in the build. So the metadata knows about these parameters, and we kind of mix them all together, and then I can. So basically, I have a very simple Arduino application here. I'm just going to flash some lights, and basically, it takes care of understanding what compiler you're using. It also takes care of understanding how to flash the build onto the board, which is doing right now. So the thing with ESP82, these builds are pretty big, and I've only got it at 115 kilobaud, so it could be faster. There we go. And now we got flashing lights. So you can't have a CDT demo without flashing lights. It's true. The other main thing that we've done, and this is something that we've added over the last year, is integration with the target management terminal. So we've added a Arduino serial monitor, which is the term they use for it. And that basically hooks up to, it knows about the board, it knows what COM port it's at, which is the main thing. We can actually set it to be a different baud rate than we used to flash the device, and other different serial port settings. And you can, so then it shows up. So this is, with Arduino, this is how you do debug. It's the old printf debugging. So having access to a terminal is critical to building Arduino apps. So that's the Arduino C++ IDE. It's fairly complete. I've had actually we have a lot of users of this thing, a lot of good feedback, a lot of bugs that were raised that helped me clean things up. And basically you get things like content assist, like all the things that you expect from a full IDE works in this, where you don't get that with the official Arduino IDE. So very useful. And it's fun. So I work on little electronics projects around the house, and it makes it a lot easier. So the next thing I want to talk about is SeeMake. And SeeMake is a really powerful build system. It generates make files, but what it really allows you to do is create projects that have multiple different build artifacts. So you can have sets of libraries, sets of applications that use those libraries, and you can set up dependencies between those. And SeeMake generates a make file that will just take care of all that for you. And the syntax, it's a little weird at times, and I know a lot of people struggle with it. But when you're doing things like building a board support package, which I've been working on lately, where you have multiple drivers and multiple libraries that you're creating, and it really takes care of all the complex dependencies that you have for you. So I wanted to add support to that, to CDT, and the support is actually pretty minimal. Basically calls SeeMake, which will read the SeeMake list files and generate the corresponding make files, and then it'll call and make. We've also added support for Ninja, which is, how many people have heard of Ninja? It's way faster. It's really good, especially on Windows. And so it actually is making Windows a reasonable development environment for embedded. Been pretty excited about that. So I'll show you an example. I have a project. It uses SDL, which is a simple direct media layer library, which words don't mean too much, but it's a library used by game developers who need graphics and things like joystick I/O and mouse and all that, and it's platform independent. So this is an example. Basically, there's a picture, and then you can move it around and stuff. And you can show that. So I can select the project I want to build. I'm going to build it for my local machine first, and hit run. Again, I'm using Ninja here. And it builds, and there we go. So it's a simple little window. Looks kind of goofy. And actually, I borrowed this from some other demo that I saw. So not too sure what that thing is. It's supposed to be an owl. And so, again, a lot of this is based on, so this is the core build system. It takes knowledge of the target, so it knows you're running it on local, which in my case is a Windows x86 64 machine. It figures out what tool chain to use based on that. So it automatically selects from the tool chains you have installed on your machine which one matches. And you can actually control the priority order and help it select the one. So in this case, it's using GCC. Then you select what mode. So we have support for run, or we can run the debugger on it. Or if there's other tools like profiling or code coverage tools that you want to use. Basically, you select that in the launch bar and you hit build and run, or just run, which will just do it. And you go from there. So if I want to change the target, so I want to use my VMware, my QNX target, And again, it figures out everything for me. So again, it's running in VMware, but if I hit build and run here, it'll quickly do the build. And now it's running on my QNX target. And it's got the same, it looks the same, a little bit smaller maybe. Doesn't take up the whole screen. And really, I did that just by changing the target. And with SeeMake is also platform independent. It has a concept of toolchain file, which defines your compiler and the other tools that you use for the build, and you can reuse that for multiple projects. So all you have to do is change the target, and we automatically figure out which SeeMake toolchain and toolchain file to use, and off it goes. So one of the questions, so how do you do that? So there's another. I wanted to show something different. So there's the local machine, there's an embedded target. How many people have heard of WebAssembly? Oh, quite a few people. It's really interesting. And basically it's yet another C++ target. So the question is so for CDT, we know that there was nothing about WebAssembly or the build environment. What I wanted to get to CDT to the point where you can add something new like that without writing Java code or writing a plugin, just from setting things up in the UI. So I think I got it to the point, and this is fresh. Like I basically knew I wanted to do this, and so some of this is really new. It'll show up in our next release, which will be in December. So I added a concept called a generic target, which is very simple. It's basically a name, and then you give properties for the target. And these are, again, the properties that we use to pick the toolchain. So I created a browser target where this WebAssembly is going to run. I made up an operating system, web, it could be whatever. And I didn't specify CPU architecture because it's kind of a, I don't even, well, mainly because I don't know the name of it. Maybe WebAssembly is the name of it. But it's a virtual machine that hooks up to the JavaScript engine underneath in most modern browsers. I think Chrome and Firefox both support it. I think the Microsoft browsers are getting close. So basically we have this compiler. It's called Inscriptin, which is actually used for a JavaScript library called ASM.js, or actually more a standard, which is kind of a minimified JavaScript. And they've taken that, and it's built on Clang. And so they took that compiler, because this is kind of a similar environment to that, and just changed the code generation at the other end of Clang, the LLVM code generation, to generate this WebAssembly stuff. So I was able to add it. What I've added is the ability to add your own tool chains, or tell CDT about them. So right now, I just have wizards to add, of course that's broken, to add really just GCC at the moment. So any GCC compatible compiler, which Clang is, and we'll add more as tool chains come along, they can plug into that same menu. And I was able to tell CDT about, okay, I got a compiler, and this is the path to it, and it supports this operating system and architecture, which matches that target. I was then able to tell SeeMake, hey, here's a toolchain file that uses this toolchain. So now when I switch to the browser target, which has a different, since it's a generic target, I don't know how to debug on that target. And I'm actually using the external tools launch configurations, and I've created a script that this is going to run when we hit the launch button. That will start up this application. So I can hit that. Take the build environment is really slow, so I did that when I was sitting at the back of the room earlier, but it starts up, and here we go. We've got the same application now running in your browser. And it's really cool, and that's really the direction I'd like to take CDT, where things are a lot easier to set up. In the past, we've had to create this big, gigantic plugin XML to define the tool chain and all the options, and it was just too overwhelming. And so a lot of new users out there, a lot of the users of the C++ package especially, struggle with setting up their environments because there wasn't a way for them to tell CDT where their compilers were. And the people install them in all sorts of different places. And they have different compilers and that kind of stuff. So hopefully we're getting it to the point where it becomes a lot easier and people have become more successful just taking the C++ package and making it work. So that's the main things I wanted to show. And I created screenshots in case things didn't work out. Where are we going for now? So as I mentioned, so the big thing I think for us is as the C++ language is evolving every 3 years, it's going to be too difficult for us to keep up. And it's time to start thinking about different solutions to that. The good news is that there's an activity started by Google, and now Ericsson's participating in it, and I think we'll stick our nose into it pretty soon too. Building a language server based on Clang, and the hope is that we can build it up to be feature parity with the CDT indexer and provide language services that way. And then we get the entire Clang community helping us build this thing, and so that should hopefully give a sustainable path forward. As I mentioned, Jeff is working on Docker support for remote build. And I think there'll be some really interesting areas once we start going down that path of supporting those kind of environments. There's a wish list of things that we want to get done. I'd like to take that remote build, take it a bit farther, support other remote environments. And things like there's a Windows subsystem for Linux now, but it's really kind of a remote. It's so isolated. You have to SSH over to it. But I think we have the target management systems in order to help us get there. I'd love to have better support for desktop building. Most of the contributors to CDT are embedded systems developers or Red Hat. We work a lot in servers and stuff. And we have great support for Linux, but for Windows and Mac, especially for Windows, if you get the GNU tool set up, you're great. If you want to use Visual C++, we really have minimal support for that. Love to see that grow. And Mac, we're really missing support for on the debug side, since they don't have a GDB anymore. And there's a few other things, like just filling out features, but adding better support for Qt and SeeMake as far as editors, especially on the editor side. Long term, where do we go from here? So I don't know if people follow my blog and tweets and stuff. Last year was an interesting year. We've lost a lot of contributors. A lot of contributors to CDT have moved on to other projects. And same with the Clang stuff. It's going to be really hard for us to keep up if we don't have those contributors. So we started looking forward, looking at what's next at Eclipse. Things like, is Java. Building a C++ IDE in Java has always been weird. It's actually made us more Java developers than C++ developers. But I can't imagine building an IDE in C++ either. I know the Qt creator guys do it, but that's a tough challenge. So where do we go? So we're looking at different alternatives. Definitely looking at the web technologies, at least as far as front ends go. And maybe there'll be some interesting things that come along. But one of the things, we had the Embedded Systems Summit on Monday. There's so many really cool Eclipse-based tooling that embedded tools developers are creating for their users. So we're not going going away anytime soon. And the community's, it's growing. I got to talk to a few companies this week, and I think we're off to the races. And that's all I have. Any questions or comments, criticisms? Anything? I know it's almost snack time. Well, again, if you have any questions, please stop me in the halls. A lot of people have done that this week, and I love answering your questions and learning how you're using CDT. Thank you very much.